Good day, everyone. Welcome to That Friendly Writer's Statistics and Data Analysis tutorial videos for TVL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll learn about the sampling distribution of the sample means. All right, let's get started. Usually, a population consists of 100, 1,000, or even millions of values. But for today, let's start out with something small. Here's an example. Let's use the population values 8, 12, 0, 4, and 6. We're going to construct a sampling distribution of the sample means. Let's use a sample size n equals 4. First, let's identify the maximum number of ways we can generate samples of size n equals 4. We use the combination 5C4, where 5 is the size of the population, while 4 is the target size of the sample. Upon doing the combination formula, we get the result of 5, which is the maximum number of ways we can do this. This is not our concern, so don't worry about this. We just identified how many we are going to list. And since we are expected to list 5 samples of size n equals 4, we begin listing such samples. One such sample is 81204. To get their sample mean, we add these values, 8 plus 12 plus 0 plus 4 equals 24. Then divide the answer by 4 values. 24 divided by 4 is 6. So the sample mean x bar is 6. What happens if we unlock one sample? The average is 6 divided by 1 because there's only one sample unlocked. The answer is 6. Let's get another sample, 120416. Take note that this is a unique combination of a sample. The sample mean is obtained by the same process. So the sample mean is 8. What happens if we are able to unlock this second sample? The average of this is 6 plus 8, which is 14, divided by 2, equals 7. What's the point of doing this? Let's continue instead. At this point, you may want to try giving the rest of the sample combinations of size 4. Give their respective sample means as well. Pause this video to try this for yourself. Alright, here are my answers. I have listed my samples and their sample means are 6, 8, 7, 9, 10. Now, about their averages. When I unlocked 3 samples, I would have 6 plus 8 plus 7 equals 21 divided by 3 equals 7. If I unlocked 4 samples, I would have 6 plus 8 plus 7 plus 9 equals 30. Divided by 4 numbers equals 7.5. What's the point? So if I unlocked all 5 samples, I would get an average of 40 divided by 5 equals 8. What's so special about this average if I get all possible sample means? This is called the mean of the sample means, or simply called mu of x bars. In this example, the mean of all sample means is 8. And it turns out, the original population, when you add all the values and divided it by the population size, the population mean mu is also 8. And this is not a coincidence at all. The mean of the sample means, also known as the average of the averages or mu of x bars, yields the same value as the population mean mu itself. This is fantastic. This shows that when we complete all the sample size, the mean of all sample means will equal to the mean of the original numbers, or the population mean mu itself. This is the essence of the sampling distribution of the sample means. But does this have any use in real life? In our example, we only used 5 values. What if we have millions of values? This shows that if we can get more and more samples and their means, the more idea we may have about the population, even if we have millions of values. We may not get the actual mu, but at least we may close in to its actual value. And hopefully, our estimate will be a close to the true mean mu. Error is expected, yes, but we could try our best to make a very good estimate for it. How? By getting more and more samples as we can. And this is the essence of the sampling distribution of the sample means. Now, for your practice, a population size big N equals 4 consists of the values 8, 4, 6, 12. List as many samples as you can. Use sample size small n equals 2. There are 6 combinations you may try to identify. Afterwards, get the respective sample means. The first sample has been unlocked for you. Find the others. Check your work by getting the mean of all sample means and see whether it matches the original population mean mu. Alright, this concludes our video for today. Hope you learned something new. Have a friendly day!